Hello everyone, my name is Abhishek and welcome back to my channel. Every DevOps and SRE engineer today wants to understand what is MLOps, what is AIOps. If they have to learn one of these things, which one is going to be easy for them? Also, a lot of people have this question, will MLOps or AIOps replace DevOps and SRE in future? Watch this video till the end, you will get answers to all of these questions. And to make learning interesting, in today's video, I have architecture diagram for both AIOps and MLOps. Using these architecture diagrams, we will understand how they work internally. Also, towards the end of this video, I will go through quick slides just to help you with revision or revising the concepts that we learned today. In future, if you want a quick revision of AIOps and MLOps, you can use these architecture diagrams and also you can use the slides that I prepared. Now, without wasting any time, let's get started with AIOps. So AIOps stands for AI, that is artificial intelligence for IT operations. If I have to put this in very, very simple terms, AIOps is an extension to observability. What exactly that means? In today's world, there are various sources from which you understand internal state of your system. For example, metrics, logs, traces, network appliances or cloud networking that you have configured, servers, applications. From all of these sources, you understand internal state of your system. So they all emit some kind of information. What DevOps or SRE engineers do today, they set up observability. So they collect all of this information. They store the information, maybe using Prometheus, Grafana, ELK stack, OpenTelemetry, Jaeger. So using these tools, they collect the information and they store the information. And they help you with visualization of the information. Also, they help you with querying the information. What DevOps and SRE engineers do today, they set up some alerts. So on the dashboards that you can see, they will use some queries to set up an alert. For example, if the CPU hit 90% for a specific microservice, or if a microservice is using more than 90% of CPU, then an alert should be sent to the Slack. Or maybe if 99% of requests, less than 99% of the requests are success for a microservice, then an alert should be sent to the corresponding team. Or maybe if there are 500 internal server errors out of 1000 requests, 1000 API requests, then a notification has to be sent to the on-call engineer. So these are some kind of alerts that DevOps and SRE engineers configure in today's world. However, the problem with these alerts, these are very limited. From the previous experience or from what they understand about the state of the system, DevOps and SRE engineers configure these alerts. But what about unexpected patterns? See, even after companies setting up a strong observability, there is 5% or 10% chance that some of the issues go unnoticed and they directly impact the production system. It's not that companies set up observability with the limited knowledge and their applications are going to run reliably on production. No, that's not the case. There are definitely some unexpected patterns. Let's say the CPU is set for 90% to fire an alert, but there is one microservice that all of a sudden, which was using 20% of the CPU limit that is provided to it, to 70%. So one fine day, there was a CPU spike from 20 to 70%. And this spike only lasted for 2 minutes. Because the alert was set up at 90%, this was not noticed. Quite obviously, DevOps engineer, SRE engineer cannot keep monitoring hundreds of dashboards. They rely on alerts. But this particular thing broke the next day. So before day, there was a spike, there was unexpected pattern which went unnoticed. And next day, during the same time, from 20%, it hit 100%. And because of which, microservice went down. Imagine if someone would have caught this unexpected pattern. Someone would have caught this anomaly. In technical terms, we call this anomaly. If someone would have caught this or performed anomaly detection, then definitely the production system would not have gone down. This is just one example. There are thousands of such possibilities, right? Maybe you have configured limit for 500 internal server, 500 internal server errors out of 1000 requests, but there were two internal server errors. Every day, there are usually zero. But for the last 4 days, the internal server errors during a particular time frame, maybe 8 a.m. to 9 a.m. in the morning, they hit two internal server errors, or maybe 1 to 2 internal server errors. Even this has to be analyzed by someone, like why there are internal server errors only during a particular time frame of the day. Now, these things cannot be predicted by a human. And this is where AIOps comes into picture. So what DevOps and SRE engineers do to the existing observability, they add AI. So basically, AI will perform anomaly detection. AI has an inbuilt prediction engine, and using that, AI tries to predict what is going to happen. AI is going to tell you, hey, every day between 8 to 9 a.m. in the morning, I see some issue with your payment service. Do you want me to fix it? These days, there are AI ops tools which are capable of setting up an alert by themselves. So they will ask you, do you want me to set an alert? Or some of these AI ops tools are actually capable of fixing the issues. Maybe they are going to fix the issue by adding more resources, or maybe they are going to fix the issue by performing a restart of the server in an amicable way. Now, anyways, what DevOps and SRE engineers do as part of AIOps, or you might call it as AIOps engineers, what they do, they add AI to the existing observability system. But Abhishek, do we or do AIOps engineers develop this AI? They can actually do it. In fact, that is how it started. But at this point of time, every observability system, including Grafana, so it can be Grafana, it can be Datadog, it can be Dynatrace, it can be Manage Engine, all of them support AIOps as a plugin. Even PagerDuty supports AIOps as a plugin. So these days, it's easy for AIOps engineers or DevOps and SRE engineers. They just need to know how to configure the plugin in the existing observability system. Let's say if they are already using Grafana, they just need to know how to enable this plugin or how to enable this add-on in the Grafana cloud. Of course, the AIOps solutions are not available as part of open source softwares. So if you're using an open source observability, you need to work on setting up your AIOps. I have taken an example and I've shown that in AI assisted DevOps series. I will try to put that link in the description as well. We have used random forest and I have explained how you can perform AIOps using log analysis. Anyways, going back. So today the life of DevOps, SRE or AIOps engineers has become very simple. Companies can afford this AIOps add-on. So they just have to go there and enable the AI extension or AI add-on. And then it can also set up some dashboards, the anomalies that it has identified, the anomalies that it has detected. Apart from your regular dashboard, it will set up an additional dashboard and it will show you that, hey, these are the things that I have identified. Do you want me to take an action, or do you want to take action by yourself? If you don't want dashboard, they are also quite capable of sending you the notification on your mobile, on your Slack, or maybe a text message to you. So final thing, what AIOps does, it performs something called anomaly detection, right? If someone asks you what is anomaly detection, this is exactly what I've explained in the last 10 minutes. So as part of anomaly detection, AIOps solutions use machine learning to identify deviations in behavior and predict incidents before they actually impact the services. And that is exactly what I have here as well. So anomaly detection, it uses machine learning to identify deviations in behavior and predict incidents before they actually impact the services. Just like I explained about the 500 internal server errors or unexpected CPU spike. Before they impact the real system, your AIOps predicts that something is going to happen. So this way, company can enhance the reliability of the application. Companies can enhance the availability of the application. They can save unexpected downtimes. Okay, now to become a AIOps engineer, what exactly you need to learn? In fact, if you are a DevOps engineer or SRE engineer, it's very simple. You just have to go to these enterprise observability platforms and just learn how they offer AIOps as a solution. I'll put some links in the description where I have already explained how you can do this in Dynatrace, how you can do this in Manage Engine that is provided by Zoho. I have a quick demo as well in those videos. So I'll put the link in the description. You can understand, or you can go to these enterprise observability platforms and read through the documentation. In a nutshell, AIOps is not a major threat because it has become very, very simple. Anyone can upscale and they can just add AIOps to their profile. It would just take a weekend for you to understand how AIOps works. Now let's head to the giant, that is MLOps. There is a study that says 80 to 90 percentage of machine learning models never actually reach production. Why? You will understand once you learn about the MLOps. Like, what exactly is MLOps? I have made many videos on MLOps. I'll try to put the links in the description, but for the purpose of video, I will repeat things. So just like software development lifecycle, so when you are dealing with traditional applications, there is a software development lifecycle that you go through. For example, requirement gathering, developing the application, building the application, testing the application, deploying the application, monitoring the application. Now imagine if a company performs all of these activities manually. So every time a developer works on a feature or comes up with a version of a feature, imagine if the company or engineers have to do these things manually, that is, develop it. Once it is developed, build it. Once it is built, deploy it, test it, and monitor it. If they have to do this, all of these things manually, so the feature or the new release is going to take at least 2 to 3 months. This is where DevOps comes into picture, and DevOps accelerates the software development lifecycle. So using DevOps, it does not take 2 to 3 months. Maybe it might take 2 to 3 weeks. Same is MLOps. MLOps is actually inspired by DevOps. It applies the same concept to machine learning lifecycle. So in the machine learning lifecycle, initially, so let's say someone has to develop a machine learning model. Initially, data has to be collected. Maybe someone is working on a weather forecast application or a climate forecast application. So to develop the model which the application is using, initially data has to be collected. Maybe the data scientist has to gather information of last 50 to 60 years. of the weather, climate of the particular place. Then the data has to be prepared. The data might not be organized. The data has to be serialized, or it has to be put in a format that is easy to understand. Now, once the data preparation is done through some pipelines, through some data pipelines, data might be prepared. Once the preparation is done, model has to be developed, because not every data can be effectively read through the same machine learning algorithm. So the developer might have to come up with a new machine learning model or an ML model. Once the model is developed, the model has to be trained. Initially, the efficiency might be 20%, 30%. Constantly training the model using some advanced mechanism, uh, they enhance the efficiency of the model maybe to 70%, 80%, and then they perform the model evaluation. Then the model has to be deployed, and finally, model has to be monitored. And every time new data is added, unfortunately, model performance goes down. So again, it has to be retrained. So this is a complete loop. So every time new data is added, or every time new feature is added to the model, every time model is enhanced, this entire thing has to be rerun. And this is a very constant process. So that's the reason why, because MLOps did not exist, machine learning models never actually reach production. So 80 to 90 percentage of machine learning models, they were developed on the local systems. Maybe the developers were performing, or the data scientists were performing some of these activities locally, but they were never getting these models to the production, because this entire process takes a lot of time and they have to iterate this multiple times. So this is where MLOps came into picture, because the same problem was solved in the traditional lifecycle management using DevOps. So MLOps is hugely inspired by DevOps, and MLOps tries to accelerate this entire process. So as an MLOps engineer, you might be using MLflow, or you might be using Kubeflow, or even GitHub Actions, Terraform, these kind of tools to spin up the infrastructure that is required to run the CI pipelines, to run ML pipelines, and to run data pipelines. So using data pipelines to prepare the data, using Kubeflow or MLflow, maybe to build the model, train the model, evaluate the model, deploy the model. Sometimes GitHub Action can also be used, and Terraform to spin up the infrastructure. MLOps engineers accelerates this entire process. Now, this number can significantly be brought down. However, MLOps is still evolving. It's not as mature as DevOps. Tools like Kubeflow, MLflow, GitHub Actions are making things simple, but we are a long, long way to go. To bring this number from 80 to 90% to maybe 20 to 30%, it will take a lot of time, because a lot of people are still learning MLOps. These tools are also maturing. So it is a good time for someone to learn MLOps, but opportunities are limited. Now, why do I say opportunities are limited? Because every company today develops a software application, but unfortunately, not every company today develops or needs their own ML models. A lot of companies use open source ML models. A lot of companies get the ML models from the outsourcing, and a lot of companies don't actually need ML models itself. Maybe if you're a consulting company, you need a software application, but you don't need a model. Maybe if you are a e-commerce company, basic e-commerce company, you need a software application, but you might not need ML model, right? So for all of these things, MLOps is still evolving. And if you want to become an MLOps engineer, you should focus on learning MLflow, Kubeflow, GitHub Actions, Terraform. These are some of the things. And also you need to learn how to build the data pipelines. I also have a complete defined MLOps roadmap. I'll also try to put that link in the description. Now, what is the difference, right? What is the difference between AIOps and MLOps. Now, after this complete explanation, you might have realized both of them are totally different. AIOps is dealing in the space of IT operations, whereas MLOps is dealing in the space of machine learning operations. So they both are not at all common. A lot of people get confused. AIOps and MLOps are similar. No, they are totally different. And again, a lot of people get confused between AIOps and AI assisted DevOps or Gen AI for DevOps. Again, they are different. Using Gen AI for DevOps is maybe for you to generate Docker files automatically, or maybe to generate Kubernetes manifest automatically. Whereas AIOps is to predict anomalies. This is the classic use case of AIOps. AIOps does not deal with generating Docker files. AIOps does not deal with automatic deployments. All that is done through Gen AI for DevOps. People also call it as AI assisted DevOps. Now, which one is simple, right? This is the final thing. Which one is simple to learn? Quite obviously, AIOps is something that you can easily upscale with, because all that you need is an access to an enterprise observability platform. Once you get access to the platform, fortunately, a lot of companies these days also have sandboxes. Like I told you, I'll put the links in the description for Manage Engine, where I've also already shown you in that particular video how to sign up to the sandbox. Dynatrace also has a sandbox. You can also get started and watch those sandboxes. So basically, they are demo environments where you cannot modify the things in the demo environment, but you can actually see how AIOps works. So this is about today's video. Finally, I'll just go through these slides for your quick revision. So MLOps versus AIOps, both of them are not similar. Only similarity between them, both of them deals with automating the operations. What is MLOps? Operationalizing machine learning at scale. So there is a life cycle called machine learning life cycle. MLOps focus on automating the life cycle. MLOps automates the end-to-end ML pipeline from data ingestion to retaining and monitoring. It also helps you with compliance and governance, and it also helps you with tools and infrastructure. For example, MLflow, Kubeflow, Terraform, versioning, and deployment. There are different stages in ML lifecycle, like I told you. Data engineering, where you gather the data, where you clean the data, where you process the data. Then model development, model deployment, and model monitoring. When it comes to AIOps, AIOps is about analysis. So aggregating the logs, metrics, traces from different IT systems and collecting the information, storing the information. Once this information is stored, AIOps solutions, they detect some patterns, they perform anomaly detection, they identify any future incidents, or they predict any incidents that are going to happen, and they perform automated remediation. It doesn't have to be remediation all the time. Maybe they can send you some notifications through Slack or email. But if you allow these systems to perform any kind of remediation, they can also do it, probably by auto scaling or probably by increasing the resources. These are some of the things that AIOps solutions do. Now, when it comes to MLOps versus AIOps, which one is easy? As I told you, it is easy for you to get started with AIOps. It is easy to upskill with AIOps and add that to your resume. There are definitely challenges with these systems. For example, if you look at AIOps or MLOps, as of today, toolchain is very, very complex and it is also limited. I talked about AIOps. As I told you, every enterprise observability platform, they have an add-on for it. But if you want to use open source solutions, they are very limited and they're very complex. And also the quality, whether it is MLOps or AIOps, both of them are still maturing. You cannot completely rely on these solutions. In future, they will definitely perform better. But right now, human oversight is required. So with MLOps and AIOps, humans should work and get the better results from the AIOps and MLOps systems. In future, maybe we might be dealing with agentic AIOps, or we might be dealing with unified MLOps, model ops, or we might be dealing with responsible automation. But this is something future. We haven't reached to the point where we have perfect AIOps or MLOps tools as of today. If you want to get this information, like if you want to get these slides and architecture diagram, don't worry, I'll be adding it as part of our newsletter. So if you subscribe to our newsletter, you can get this information for absolutely free of cost. So I'll put both the slides as well as architecture diagrams in one of the newsletter that we are going to write. So subscribe to the newsletter and get that information straight away to the inbox. You can find the newsletter information in the pinned comment. So just look at the pinned comment, you will find the subscribe URL, and then you can get it to your inbox. Thank you so much for watching today's video. I hope you found this information useful. See you all in the next one. Take care. Bye-bye.